A basic understanding of rectangular coordinates, or Cartesian coordinates they're also called, is absolutely essential to creating CNC programs. This is one of the most important aspects, and if you get this part down and really understand it, it's going to make your life a whole lot easier because it applies to any machine you're going to program or ever run in the future. So you really want to understand and have a basic understanding of rectangular coordinates and how they work. If you're already familiar with rectangular coordinates, you may want to fast forward through this video, but I'm going to get pretty basic. We're going to get into some real basic geometry here and start discussing building geometry from a point all the way up to a plane into a cube, because I don't know how familiar you are with those concepts or how familiar you want to be or what you remember from your high school geometry or grade school geometry. So we're going to start real simple because this is so important. We don't want to leave something out and leave something hanging for you in the future. But 300 years ago there was a French mathematician by the name of René Descartes, and he decided that you can determine any point in space by using three mutually perpendicular axes. Now if you look at three mutually perpendicular axes, you'll see you have a vertical line coming down, a horizontal line coming through, and another line going in and out. And they're all at right angles at each other, which means they're at 90 degrees, right? They're just 90-degree angle between this line and that line, and a 90-degree angle between this line and that line, and we're going to go over that. But he decided that any point in space could be described using three mutually perpendicular axes. And he was the first to do that, and that's why they're called Cartesian coordinates. But they're also called rectangular coordinates, and the two terms are basically interchangeable. And we're going to start discussing those now to get your foundation for CNC programming, so it's really solid when you go to read a CNC program, or you're looking at a CNC program or want to write one. You have an idea what's going on, what those X, Y, Z coordinates actually mean. Okay, let's quickly review some real basic geometry. As you probably recall, the most basic unit in geometry is the point. The point is a location in space that is not an object. So it doesn't have width, breadth, any definition other than a location. Remember your 7th grade geometry, you remember that lines, for example, actually are considered to extend in infinite directions, both right and left, up and down, whatever, but they're infinitely long. So the way you determine where you are on a line is you create an origin point and then you count off to the right or left of the origin point. Of course, your increments can be in any unit you want. They can be metric and centimeters and millimeters. They can be in miles, they can be in feet, they can be in inches, whatever. For purposes of this training program, we're going to be using specifically inches, unless there's some reason to do otherwise. So unless I state otherwise, any increments we'll be talking about here will be in inches. Now you can see from the line in front of you that there's an origin point in the center, and then we go 4 inches off to the left and 4 inches off to the right. Anything to the left of the origin point is going to be considered a minus number. Anything to the right will be considered a positive number. If the line is going up and down, anything below the origin point would be a minus number. Anything above the origin point would be a positive number. Even though our line is somewhat arbitrary, by adding our hash marks at the inches, we now have kind of a useful tool. We can use this to measure distance and direction from the origin point. For example, if you go out 3 inches to the right, you're at x3. But if you want to go 3 inches minus, then you have to move to the left to get to x minus 3. We also know that if we want to go from x minus 3 to x plus 3, then we would actually have to move 6 inches. 3 to get back to the origin, and then 3 to get from the origin to the x plus 3. As simple as that sounds, That's actually a pretty fundamental part of NC programming, particularly if you're incremental programming, which we'll get into a little bit later. But knowing your distance and direction is very critical if you're going to properly position the tool around the part and make good cuts. Using the same method, you can also locate a point on a plane numerically. In the example, notice that a circle has been located in the upper right-hand corner. Also notice that we now have two solid lines, and the point where the lines intersect is the point of origin. This is indicated by a red marker off to the left of the origin point. You'll also notice that the line we added, the vertical line, is the y-axis. To assist you in determining the numerical address of the circle, I have provided two dimension lines. The horizontal dimension line passes through the circle and intersects the y-line 2 inches above the origin point. The vertical dimension line passes through the circle and intersects the x-line 2 inches to the right of the origin point. By counting the segments from the point of origin along the x and y lines, you can see that the numerical address for our circle is x 2.0 and y 2.0. Finding the distance and direction between 2 points on a plane is just like it was for finding distance and direction for a point on a line, except you're dealing in two different axes. So in our example, locate points A and B on the example. Now in this example, you can determine the distance and direction from point A to point B. This is really very simple, and this is how you do it. Assuming the hash marks are 1 inch apart, notice that from A to B, it is 5 inches in the negative direction or down the y line, and 2 inches in the negative direction or to the left along the x line. Also notice that if you were to describe the distance and direction from point B to point A, the values would become positive. So if we are starting at point B, you would have to go up the y line 5 inches and then cross over to the x 2 inches. Now what you're starting to see here is that not only locations but also directions are important. It makes a difference whether you're moving from A to B or B to A. The ability to easily recognize distance and direction from one point to another will become especially critical when you're working with arcs, because you'll always have to know where the arc center is in distance and direction from the start point of your arc. But that's a topic that we'll be getting to a little later. Many of you probably remember growing up and you'd get a tablet or a piece of paper with a bunch of dots on it, and your job as the kid was to connect the dots and make whatever picture. Well, I think of CNC programming as being very similar to that, particularly when you're manually programming, because what you do when you're laying out your program is you actually create the individual tool locations, much like the dot on those pictures, and you put your tool locations all around the drawing. And when you do that, you type in there, or write in, depending on what you're using, their XY coordinates. And then when you go about programming, actually writing the G code, it's a matter of putting the right code to go with the right dots so you can connect them all together. What we're going to be doing in the early parts of this program is learning how to develop those dots so you put them in the right spots. Then after that, we'll go about creating the commands to connect those dots in a way that's meaningful and makes a good part. So, after you have determined how the part is to be machined, which tools are to be used, and how you're going to locate the part on the machine, the next step is to define the part in a language that the machine understands, and that is basically numbers, hence the name numerical control or computer numerical control. All of the programming points on a part will be one of the following. They'll either be intersecting points, tangency points, or specific points such as hole locations. For those of you that might need a review of these subjects, let's discuss them real quickly. Of course, intersecting points are points that are created whenever two lines of geometry intersect. In front of you, you see a drawing of two lines intersecting, creating an X. That point where they intersect and basically make the X, that would be an intersecting point. Now the next example is a picture of a rectangle or a box, and again we have the same situation. We have lines intersecting to make a point. The sides of the box or the sides of the rectangle intersecting create an intersecting point. Intersecting points can also be created when a line intersects an arc or a circle. In this particular case, you can see where the line passes through the circle. That point that's created where it passes through the circle would be that particular intersecting point. As you can see from the next drawing, it doesn't have to be a line at all. You can have a couple curves meeting together, creating intersecting points. And in this final example, we have several different examples of lines meeting with curves or lines making corners, all creating intersecting points. Tangency points are different than intersecting points, and they always involve at least one curve or an arc, and either a line or another curve. And what makes them different is if a line goes through an arc and actually would pass through it in two places, then that would be an intersecting point. But tangency points are created when a line just skips off the side of an arc so that it actually only contacts the arc at one point. The same is true as whether you have two arcs or two curves meeting together. If they meet in such a way that they only create a single point, then that would be a tangency. If they overlap just a little bit, then that creates intersecting points. So tangency points are created when they just kiss each other just a little bit and only create one point of contact. In this first example, off to the left we have an angled line that just skips off the side of the first circle. That point where the line just barely touches that circle on the left-hand side would be the tangency point. And as you look farther to the right, you see we have two arcs that are actually just kind of touching each other. That point at where they just touch, that single point where they just touch, would be considered a tangency point. In the next drawing, we actually have a fillet created by a horizontal line blending with an arc that eventually blends with an angled line. Starting from the left, where that horizontal line just kisses what would be the top of that arc, well, that is a tangency point. Then as you follow the arc around clockwise, you see it eventually blends with the angled line coming up from the right. Of course, where that angled line just kisses off the side of that fillet or that arc, that of course is the tangency point on the right-hand side of the fillet. On the next drawing, which is a little more complex, actually has four tangency points. The first tangency point is created where the angled line coming up from the left actually blends with the clockwise arc. The second tangency point is created where the clockwise arc blends with the counterclockwise arc that's a little farther to the right. Then as that counterclockwise arc blends with the third clockwise arc, that creates a third tangency point, and the final tangency point is created where that last clockwise arc actually blends with that horizontal line heading off to the right. Feature-specific points are much simpler. As you can see in the drawing, we have basically 5 holes in the middle of a part. Well, the center line, or the center of each one of those circles that represents those holes, would be the specific point that you would want to program to. That would be the feature-specific point. The nice part about feature-specific points is they're usually pretty well laid out on the drawing. They tell you exactly where they need to be in terms of dimensions from some known feature. Congratulations! You have just completed one of the most important lessons in the CNC training program. Of course, that's the discussion of Cartesian, or what is also known as rectangular coordinates. Without a good understanding of rectangular coordinates, it's very difficult to be very effective as a CNC programmer. So to test your knowledge, and to make sure you have these concepts down before we move on, there's a quiz. And in this quiz, you're going to be asked to determine the distance and direction between several pairs of points shown on page 14 of the manual. The actual questions related to the quiz are on page 15 of the manual. But to get you started, I'm going to run through a simple example going from one point to another, so you know exactly what's expected of you as you answer the questions on page 15. For this example, I'm going to help you determine the distance and direction from point 5 in the upper right hand corner down to point 7 in the lower left hand corner. So the first thing we're going to do is we're going to start at point 5, work our way down to the X line, and then just start counting hash marks to the left or in the X minus direction. As we count those hash marks, we are counting the distance and the direction from point 5 to point 7 along the x-axis. In this particular case, we'll have counted x minus 14 or 14 hash marks in the x minus direction. Now we're going to do the same thing for the y-axis. We're going to start at our circle. We're going to go over to the y-axis. In this case, we're going to be counting down or in a y minus direction. We're going to count all the hash marks between 0.5 and 0.7 along the y-axis. If you've been keeping up, you'll know that we counted down or in the y minus direction 18 hash marks. So the distance and direction from 0.5 to 0.7 along the y-axis would be a y minus 18.